Hello, welcome. We've got a few weeks left here. I wanted to give you a preview of what is coming up, as well as this is a lesson on how to determine the scale factor when you are scaling recipes. And so I'm going to share my screen with you. All right, and we're on week 31 right now. Go to week 31. Week 30, a lot of us was still on spring break, so there was an assignment week 30, but if you did not complete it, you don't have to. It exempted you. Week 29, there was an assignment that was due, and if you did not turn that in, please do so. But today's week 31. And our first assignment here is to simply read the textbook pages about scaling recipes, all right, and then answer some questions on the note page regarding how you determine a scale factor. Right? And then you'll have some practice actually determining the scale factors on from this link here. First, let's look at the textbook pages. Skip this checkpoint here. We go down to it says scaling recipes. All right, converting measurements is often done when scaling recipes. All right, scaling is the process of calculating new amounts for each ingredient in a recipe when the total amount of food the recipe makes is changed. For example, a recipe that serves 4 people may be scaled for use in a restaurant that plans to make 50 servings of the recipe. Similarly, a recipe used by a banquet hall that normally serves 100 people may be used to scale to make only 12 servings for a smaller party or a small party. So we can either scale up or scale down. Right? The recipe is made just for a certain amount, right? That's the yield, right? But maybe we want to make more or less of that, so we've got to scale the recipe. A recipe may also need to be scaled based upon the availability of one of the ingredients. For example, a recipe may require 20 pounds of ground beef, but only 15 pounds of ground beef are available. A food service employee needs to know how to adjust all the other amounts in a recipe to account for the variable amount of a key ingredient. Okay, so that's another reason that we might want to adjust or scale a recipe. Food service employees not only need to know how to calculate new ingredient amounts when recipes are scaled, but also need to understand how scaling can affect other elements of a recipe. For example, depending on how significantly the recipe is scaled, the units of measure used for some ingredients may need to be converted to making measuring the ingredients more practical. An example of that is after you scale something, if it says, hey, you need 16 tablespoons of cocoa powder, it's going to be a lot easier for you. Instead of measuring out 16 tablespoons, it's going to be easier for you to convert, okay, into a larger unit of measure. So those 16 tablespoons, you can convert that if you remember that 16 tablespoons is the same thing as 1 cup. That'd be a lot easier to measure, right? In addition, cooking times or temperatures may need to be adjusted, or cooking equipment of a different size may be required. So that's another thing to consider when you're scaling recipes. A well-written recipe will contain all the information that needs to be considered when a recipe is scaled. We're not going to go over this. Okay, I assume you probably know this already. Just to point out, the yield is something that's important that we're looking for. Sometimes portion size helps us calculate the yield, okay, if the yield isn't given directly. But yield is important. That's how much total food or beverage, right, the recipe will produce. And here it is, the total quantity of food or beverage that is made from a standardized recipe. All right, so I'm going to switch over to the questions now. Answer the questions on the notes page. Scaling recipes, determine the scale factor. Right, now you're going to need to, on a separate piece of paper or a doc or something, answer these questions. What is scaling? What is the yield of a recipe? How do we know how big a place is in real life if we have only a scale drawing? Okay, all 3 of these we can answer from what we just read. All right, so I'm going to switch over to a place where I can type in the answers to these. What is scaling? Well, there was a definition right there in the textbook page. It doesn't necessarily have to be word for word what it says there. All right, you're going to type in what is scaling. All right, so scaling is the process of changing the ingredient amounts when you change the yield. All right, so if you desire to have a larger yield or a smaller yield, then the ingredient amounts need to change too. So it's that process of getting all those ingredient amounts correct, okay, when you're changing the yield. Well, what is the yield? Well, the yield is how much food or beverage the recipe makes in total. Okay? So again, some sort of description there along those lines. And it is defined. You can write down exactly what's in the book if you want, or you can write in your own words. All right. How do we know how big a place is in our life if we only have a scale drawing? All right, so here's another example of scaling other than in culinary. Okay, think you have a map. You've got a map, right? How are you going to tell, all right, how far it is to your friend's house looking at the map? Well, Google Maps will tell you if you just do it, okay? But old-fashioned thinking, you had only a map, and you could look, and what you would do is you'd find the scale factor on that map, okay? And then you would actually multiply the distance by the scale factor. What I'm just going to put simply here is we would use the scale factor. Okay? And that kind of leads us into what we're going to do next, okay? The process of scaling a recipe, the first thing we need to find is the scale factor. Okay? I'm going to go back to the notes page. Sorry, that's not the notes page. This is the notes page. Okay. All right, so right under here, let's skip down to scaling based upon yield. The most straightforward example of scaling a recipe are doubling the yield, where all the ingredient amounts are simply multiplied by 2, or having the yield by dividing all the ingredient amounts by 2. The scaling does become more challenging, though, when the yield is changed by a factor that is not as simple as doubling or halving the recipe. For example, a recipe that normally yields 3 gallons may need to be scaled to yield 10 gallons. Likewise, a recipe that makes 12 portions, 6 ounces, may need to be scaled to make 30 portions, 9 ounces. Okay. Regardless of the reason for scaling a recipe, the scaling process starts out by calculating a scaling factor. That's what I just said. Scaling factor, that's what we need to find first. All right, so what is that? Well, it's the number of each ingredient amount and the recipe yield they're multiplied by in order to increase or decrease a recipe. Okay, kind of a long mouthful, okay, but it's what we use, the number that we use that we use math, that we multiply to find the new ingredient amount. Okay, and how we find the scaling factor is pretty simple. All right, we take the desired yield over the original yield, and what over means, this fraction here, means divided by. So to find the scaling factor, we take what we want, how much stuff we want to make out of this recipe, the desired yield, divided by what the recipe says it makes. Okay. So I'll switch back to the problem here. Not that one, this one. All right. Standardized recipe yields 48 cookies. So remember our formula here is the scale factor, or I'm just going to say desired yield divided by desired yield, not multiplied, but divided by the original yield will give us our scale factor. All right, so what is the desired yield? Well, the desired yield is 120 cookies. We want 120 cookies. What's the original yield. Well, what did the recipe say it would make originally? 48 cookies. So to find the scale factor, we take 120 divided by 48, and that means that our scale factor is going to equal, do that in a calculator, 2.5. There's our answer. Okay, simple as that. Let's do one more. The standardized recipe yields 16 gallons of soup. You need to make 4 gallons. What is the scaling factor? All right, I would recommend that you do this, pause the video and do this one yourself first to see if you can get it. Desired yield. I want to make 4. The original yield made 16. So we've got desired divided by original, and this is going to equal 1/4 or 0.25. Okay, so this time, remember, it's a decimal, but that makes sense because we're actually shrinking the recipe. We're making it smaller. So we take this number and multiply it by all the ingredient amounts and figure out what our new ingredient amounts are. All right, let's do this one here. The standardized recipe makes 7.5 ounces of salad. You need 105 ounces of salad. What is the scaling factor? Again, I would recommend you pause it, do it yourself, and then check your answers. So desired yield, in this case, is 105 ounces. And I'm going to say that the 7 1/2 is the same thing, so I can type my calculator. 7.5. So I take my desired yield of 105 divided by 7.5. And you should get 14. So our scale factor is 14. All right, so those are pretty straightforward examples. This next one's a little more thinking, but it's still the same process. Okay, a standardized fish recipe makes 16 6-ounce portions. So imagine after you're done making this recipe, you'd have 16 plates that have 6-ounce pieces of fish on them. Okay? But it needs to be scaled up to make 24 plates and that have 8-ounce pieces of fish on them. Okay? We're figuring that our guys want to eat more than 6 ounces, and we're having more than 16 people there. We're having 24. What is the scaling factor? Recall, okay, that yield is the total amount of food or beverage the recipe produces. Okay, so we have to take both of these numbers here to find the original and the original yield here, and also both these numbers to find the desired yield. So we have 16 plates that each have 6 ounces of fish on them, but how many total ounces is that? So we got to first, before we do our scaling factor calculation, we got to make sure and understand how much our yield is, okay? And it's not too hard to do that, okay? If you have 16 plates that each have 6 ounces on them, how many do you have total? 16 times 6. And this is for the recipe, so this is our original. 16 times 6, which is going to equal 92, I think. No, 96. 96 ounces. Okay, that's the original yield. All right, what about the desired yield? Same process, except we have 24 plates, and we want them each to have 8 ounces. So 92 ounces. Now that we've got that straight, now we can actually do our scale factor calculation. where is desired yield over original, desired divided by original. And you should get 2. Okay, a little bit different, but it's just making sure we have yields before we put it into the form. All right, this is a extra credit one. If you guys can do this, I will give you extra credit. One additional consideration that a chef must consider when scaling recipes, and why? Well, we talked about a few. You may need to adjust the cooking time or the cooking temperature to match the new yield, right? Or you may need to convert from smaller units of measure to larger to help with measuring ingredients. All right, remember it's a lot easier to measure 1 cup than it is 16 tablespoons. All right, so those are the notes. After you're done with completing the notes, you will turn those in under week 31 in this assignment, but you also need to turn in this little practice thing. Click on the practice. It's essentially a table that you just have to fill in the missing piece of information. Most of the missing pieces of information are just conversion factors. So you're simply going to take the desired yield divided by the original yield. Okay, so for question 1, I'd write down on a piece of paper, the question 1, and do 50 divided by 10 equals 5. 2 would be 24 divided by 12 equals 2. Okay, so this shouldn't be too hard. Just it's really kind of practicing getting that formula, just doing it over and over so you kind of have it memorized. All right, you'll have some decimal numbers because in some recipes we shrink down the amount, right? That's fine. 8 and 9, a little bit of algebra. Set yourself up an equation to find for the missing piece of information. In this case, it would be x divided by 60 equals 2. Solve for x. Once you're done with these 14 problems, take a picture of your piece of paper as well as a picture of your notes and submit it here in week 31. If you have any questions, please let me know.